said, okay, that should be fine. And this. So you tell me, Tetelo, have you written your maths and physics exam or tests?
Test.
So you are done with the tests.
Yes, sir.
Okay. And then when are you guys closing in your school?
Next week, Friday.
Okay, I see. And you'll be closing for how long?
Like a week and 2 days.
Just a week. Okay. Then it makes sense. I've got a question here with me that I would like for us to have a look at, and I am going to share my screen just now. And let's see. So, are you able to see my screen?
Yes, sir, I can see it.
Okay, then it's fine. So, question number 4, obviously, you are always advised to start on a new page. And you've got 2 blocks of mass 8 kg and 4 kg respectively, which are joined with an inelastic string of negligible mass. The string runs over a frictionless pulley. The 8 kg block is on a horizontal surface, while the 4 kg block is on an incline plane of 40 degrees with the horizontal. The coefficient of kinetic friction for both blocks is 0.2. The 4 kg block accelerates down the slope. Okay, there's 4.1. Do you still remember how to state Newton's second law?
Yes, sir.
Okay, then it's fine. So for 4.2, where they say draw a labeled free body diagram of all forces acting on the 4 kg block, how would you draw those?
I would first make a dot
Okay.
and then label perpendicular normal force.
Normal force in which direction?
Perpendicular to the surface that the 4 kg is on.
Yes, perpendicular in that direction. Okay, normal force. Okay.
And then the weight straight down.
Straight down being a FG. Okay.
And then there would be tension, wouldn't it?
So always when we have objects connected by a string, there will always be a tension. It only exists if there are 2 objects connected by a string. So there will definitely be a tension. And how will that tension be?
The direction of the rope. The rope is going.
So it will be saying that direction, then we'll say tension. Okay.
Would they be friction?
The question would be, why would there be a friction? So you can just do your checking, whatever, and try to
Oh
find.
no, there wouldn't be friction.
So for example, if you say friction is there, and also if you say it's not there, there must be a reason for that.
What's the reason, sir?
Okay, so you will then need to go to the statement to check if there is something that has to do with friction on either 8 kg or 4 kg. So on the statement, you can just take your time, read through the statement, and check if there is information related to the friction. If it is there, then friction is there. If it is not there, then there's no friction. That's how you will know if friction exists or not.
Oh, it says the string runs over a frictionless pulley.
But that is the pulley and the string, which is frictionless. What about the object with or in relation to the surface? Is the surface also frictionless?
No.
Then it means it will exist. You see that last sentence, not the last, but that part which says the coefficient of kinetic friction for both blocks is 0.2. Can you see?
Yes, sir.
Yeah, so that's what makes that force of friction to exist, is because of that reason. And that's how you will do a labeled free body diagram. Makes sense?
Yes, sir.
Okay, then it's fine. Now they want you to calculate the frictional force between the surface and the 4 kg. Do you have any idea of how you would work it out?
Yes, sir.
Okay, how would you work it out? You can just take your time, work it out on your side, check if it makes sense, and if you are happy with the answer. And as soon as that is the case, then you can let me know. Nay.
Yes, sir.
Okay.
think I got it, sir.
Okay, let's see. How have you worked it out?
I would calculate the FG parallel.
FG parallel. Okay, how did you calculate it?
It's M times G sin 40.
Which is equals to M times G multiplied by sine angle. Okay. Which
is 4 times 9,8 sin 40.
9,8 sine 40. So you just need to remember that in physics, you start with the formula, then you only substitute in the next step, then last step is your final answer.
25,20 newtons.
25,20 newtons.
Down the slope.
Down slope. Okay. So what is this? Is this FG parallel or is it a frictional force?
Wouldn't it just be both?
Okay, so that means this is your frictional force. You just used the formula for that. Okay, but what is the direction of the frictional force? You say it's down the slope like that.
No, it's up the slope.
So we change that from down to up.
Yes, it's up.
Okay. Then it's fine. I'm going to remove all of this and then we're going to discuss it because regarding the formulation, it depends on what you drew being the labeled free body diagram. But this is what happens. Let me remove that as well and then discuss. So this is what happens. If we have an object on a flat surface, it's not moving, nothing is happening, it is just standing there. How many forces or what are the forces that you think are acting there?
Normal force and weight.
Yes, it's going to be the weight in that direction being Fg and also the normal force going up. So because this object is not moving up or down, so that means those forces, they cancel each other, they are equal, isn't it?
Yes, sir.
Yes, so that means force of gravity, it is equals to the normal force in this case. So that means mg, it is the one that is equals to the normal force. And if you look at this, you'll realize that it's actually mg perpendicular to the surface, which is equals to the normal force, which is perpendicular to the surface. So we don't have any other force, but we only have those two. Do you agree? Tetelo, are you still there?
Yes, sir.
Yes, okay. So this is an object which is on a flat surface. Now let's have a look at these. Let's have a look at this one. Maybe again on a flat surface. And then we have that object. Let's say now this object is being pulled in that direction by whatever applied force, and they do state that this surface, let's say it is rough. So that will mean in terms of the forces acting on that object, we are going to have this one going down, which is our FG. We will also have this one going down, which is the normal force that balances with that, because the object is not moving up and down. That's why this force perpendicular, or that force, together with that normal force, that will be equal. And then because the surface is rough, that means we will have a frictional force in that direction. Okay, so now let's try to have a look at this situation. So if an object is on a horizontal surface, but in terms of the force applied, let's say it is at an angle, in that direction, the angle formed there, let's say it's angle theta. So in this case, Tetelo, when we sketch that, we have this one that will always be there. And we also have this one that will depend on the existence of the surface. And then this one of the applied force, you see that one, it has two components. The two components, it will have this component going up. I'm not sure if you agree. This one is that one of F, a sine of an angle. And then we'll also have this one in that direction of F cos of an angle. I'm not sure if you agree with me on this one,
Yes, I agree.
Yeah, so that means in this case, it will depend on the statement if we have a frictional force. That's if the surface is rough. If the surface is rough, then the frictional force will exist on that one. And then in terms of the up and down forces, so it is actually Fg, which is now equals to the normal force, including that other component. So that means in this case, it is not just Fg being equals to normal force, but we include that other force going up. The reason why we include it is because even with an addition of this force, this object is not moving up and down, but it's moving towards the right. And what pulls it towards the right is because of F cos of an angle. This force, it's applied in that direction, but if the object is not moving in that direction, then it means it is the component that is pushing it to go towards the right. I'm not sure if you get that part.
Yes, I get it.
Yeah, so now let's look at this situation. Let me not take a shortcut and redraw it again, just so that what is it? Just so that you've got an idea. Just so that you've got an idea of how labeled free body diagrams would be for different forces. So now we do have that force again, but this time around it's a pushing force, and it is being applied at a certain angle. So in this case, in terms of the components, we are therefore going to have one going down and then the other going in that direction. So again, this one will be that one of F sine of an angle, and this one will be F cos of an angle. And then we will also have this one that is always there, being force of gravity or the weight. Then we will still have this one in that direction being the normal force, depending on the surface being rough or whatever, assuming that the surface is rough, then a frictional force will definitely exist and it will oppose the motion of the object. So that means a frictional force will be there, but in that direction. And so that means in terms of the horizontal forces, for example, if we have to use F net, which is equals to MA, for the horizontal forces, we have frictional force, we will say minus because frictional force is acting towards the right. So we assume it to be positive going towards the right, towards the left. That's when we have this force applied, but cos of an angle. And this can be equated to MA. And then in terms of the up and down forces, we have a normal force, which is the one going up, which balances with FG, not only FG, but also this force applied sine of an angle. Does it make sense?
Yes, sir.
Okay, then it's fine. So, what other? Now it means we are going to be looking at a situation where we have object on an incline. Then we'll also quickly do okay, let's say we've got an object which is on an incline, and then we have an angle there. So let's say this object, there is no applied force, but this object is moving down an incline. So in terms of the forces, we know we will always have this force going down, and then we will definitely have that one being the normal force. So maybe let's say we do have a frictional force because the surface is rough. And then the other thing that you need to be aware of is the fact that this object is moving down the incline, not because of the frictional force or the applied force, but because of that, the component of that force. So that means we will have the component of that force, which is FG parallel. The one for FG parallel, it's the one that has the sign. And then this one being the component in that direction is the one which is FG perpendicular. That is the one for cos of an angle. Do you agree with that one, Tetelo?
Yes, sir.
Okay, so there are more examples that we can talk about. But for now, let's then try to go back to that question and see how we can work it out. Something that you just need to remember is that the formula for calculating frictional force they say, isn't it this one of mu n?
Yeah.
Are you sure, Richard? Do you not remember this as the formula for the frictional force?
Yes, it is.
Yes. So now it therefore means it is equals to that mu. Normal force, we know that a normal force is equals to force of gravity. But for now, let me just leave it at that. And then let's quickly do this. So we said we are looking at that object which is on an incline at an angle of 40 degrees. So we said we have a force which is in that direction, and that force is the normal force. And then we also have this one in that direction, which is the component of that one of Fg. So do you agree, Tetelo, that this one is the one of Fg perpendicular, which is going to be the one having cos of an angle? Do you agree on that one?
Yes, sir.
So can you now see that we only have that force and that force opposing each other? So that means the normal force, it is the one that is equals to Fg cos of an angle. Do you agree with that one?
Yes, sir.
So that means when coming back to our equation, we will therefore have mu Fg cos of an angle, because Fg cos of an angle is our normal force, so it is equals to normal force. Do you agree, Tetelo?
Yes, sir.
So do you notice your mistake?
Yes, sir. I noticed my mistake.
Yes. So very quickly try to rework it, and then let's see what the answer is.
Got it, sir.
Okay. What did you do?
I calculated the FG perpendicular, which was 30,03.
FG perpendicular, which is 3, okay. Did you not continue with that formula?
What?
You didn't continue from that one there.
I did, sir.
Okay, let's substitute on that one. What did you do?
I did 0,2 times 30,03.
0,2 multiplied by okay. So what I wanted to say was mass, which is equals to 4 multiplied by 9.8, and then cos of 40 degrees. Is this what you did?
Yes.
Okay, and then you say, what is the answer?
6.
Just 6 Newton.
Yes, sir.
But wait, did you not say 30 comma something?
Yeah, the FG perpendicular is 30,03.
Let's see, without it being caused, without it being that. Tetelo. So I'm just
Sir?
saying, you just did mg without cos, without mu.
No, sir. I calculated the FG parallel and then stated that FG parallel. No, I stated that FG perpendicular is equal to the normal force. And then I took the coefficient and times it by the normal force.
And then you did not say cos 40.
I did say cos 40.
Okay, so my confusion is we have two answers. The one which is 6 when you punch all of that. So I want to understand how do you get the 30? You get the 30 if you don't include which part?
I got the 30 with the FG cos angle.
Without the mu.
Yeah.
Okay, no, I see. So that means, yes, very important to include the mu, and you must also indicate to say Is it up or down the slope?
Up the slope.
Yes, you need to also then include and say up the slope. So that should be the answer for that one. I'm not sure, but does it make sense?
Yes, sir, it makes sense.
Yes, you just need to always remember that formula. And then in order to determine your normal force, you need to know all the up and down forces. Sometimes you might find that the up and down forces, you have the component. You see, if a force is applied at an angle, there's going to be a component. You remember, Moose?
Yes, sir.
So if there is that component, then you will say mg equals your normal force. Sometimes you need to include that F applied a component. Then you make your normal force the subject of the formulas. That means your normal force will be equals to mg, where you minus F applied a sine of an angle. So that means now in that formula, this is what you substitute. You no longer just substitute Fg, but you substitute Fg minus that. That's if you'll be calculating your frictional force. That means your frictional force will therefore be equals to mu and the whole of this, because the whole of this is your normal force. Does it make sense there, Tetelo? Am I losing you?
No, sir, it makes sense.
Yeah, so that means normal force, it's not necessarily always mg. That is why on that formula, they didn't say frictional force is equals to mg or force of gravity perpendicular, because they knew that if they said force friction equals mu mg, it was never going to change. It was just going to remain like that. But in a situation where now we have applied force acting at a certain angle, then you need to know all the up and down forces. You say the up forces equals down forces, then you make that the subject of the formula. Then you will have something unique which serves as your normal force. I hope that part you got it most detail.
Yes, sir.
Yes, okay. And let's see. What else? Okay. Okay, so now take your time to look at that one or 4.4, where they want you to calculate the magnitude of the acceleration of the system. Can you see that question?
I think I got it, sir.
Okay, let's see. How have you worked it out?
I use the F net equals mass times acceleration formula
Okay, F
where
naught
I
equals ma. Okay,
so then I made it into A equals F net over mass.
a equals F net over mass. Okay,
So the magnitude of the mass is 12 kg.
okay, we have 12 kg.
And then when I was calculating the F net, I got 119,2.
19,2. But how did you calculate F net?
I checked all the forces that were acting on the weights.
It's okay. So what are those forces?
The what, sir?
So you
The forces.
say yes, the forces.
Oh, with the 8 kg, the forces exerting on it are the normal force and weight, and both
Okay,
of them will cancel out being 0.
maybe let me check. What was your final answer?
1,6 meters square, meters per second square.
1.6 square meters. Okay. No, no. Then it's fine. Let me show you the best way to go about it. So the answer shouldn't be that one. But if you follow this approach, you will never go wrong. There is something that we should be aware of. I'm not sure. Do you know that if we cut that system there, we end up having tension there and also then these tensions are the same. The only difference is that they act in opposite directions, but the value of the tension is the same. Do you agree?
Yes, sir.
So if you always cut them and you deal with them individually, it makes it very much easier. For example, we can start with F net just on the 8 kg. F net on the 8 kg is equals to MA. So what will be F net on the 8 kg? We will have tension, obviously, tension towards the right on the 8 kg. On that one, it's in that direction. Do you agree?
Yes, sir.
So that means F net on the 8 kg, we just have the tension minus the frictional force. And that is equals to MA. So what will then be the formula for the frictional force on the 8 kg? So maybe let me give you a hint. You will always need to know this. A frictional force, the formula, it's always equals to, let's just say mu normal. That's if the mu is given. Can you see there, Tetelo?
Yes, sir.
So on the 8 kg, what will then be the normal force, or how can we formulate for the normal force on the 8 kg?
Mass times the gravitational force.
Do we include the cos or not?
No.
Yes, we don't include it because it's not on an incline. So that's why we can just have starting with the mu and then mg. Then we say it's equals to ma. Does it make sense there?
Yes, sir.
So something that you need to remember is that the acceleration on the 8 is the same as the acceleration on the 4 kg. So it's like whatever that you do there, it's just to make t the subject of the formula. You do the same there and make t the subject of the formula so that you will equate them together, and then you solve for acceleration. So that means here you will have your t, which should be equals to ma, that you plus it with the mu, and then mg. Then this should be your equation number 1. I'm not sure if it makes sense what I've done there.
Yes, sir. It makes sense.
So now you go again and do F net, which is equals to MA, but now you do on the 4 kg. There it was for the 8 kg. So the F net on the 4 kg, would you agree if I say we have a FG parallel? Do you agree there, Tetelo?
Yes, sir.
That we will need to minus with the tension. Do you agree?
Yes, sir.
And then again, we will need to minus the frictional force. We will need to minus the frictional force. Okay, what will be the formula for the frictional force on the 4 kg?
Sir?
What will be the frictional force formula on the 4 kg?
Nu times mg cos.
Is it done?
No, sir. Equals to mass times acceleration.
Okay, but it has to be cos angle, not cos, nay.
Yes, sir.
Yes, so again, on this one, you will make t the subject of the formula. Say, t will therefore be equals to that mg sine of an angle minus that mu mg cos of an angle minus ma. And then this is your equation number 2. Does it make sense?
Yes, sir. It makes sense.
Yes, then all that you now need to do, you equate both the equations, because this is equals to that. Tension is the same on each of the objects. Then all that you need to do, equate, and then you solve for A, because you do have the mass, you do have mu, you do have the mass, you do have the gravity, you do have the mass, you do have G, you do have sine of an angle, you do have mu, and you do have, what is it? You have G, you have cos of an angle, you have the mass. A is what you're looking for. So can you see after you've equated on both sides you have A. All that you need to do is just to solve for A. As if you solve for X. Does
Yes,
it
sir.
make sense?
Yes, sir. It makes sense.
Yes. So you just need to be careful in terms of how you formulate. So you just need to check if your object is on a flat surface or if it's on a horizontal surface. I can say the most important part that you need to remember is this one of the frictional force. You need to know how to formulate your frictional force. And this one, it's what you calculated there. So it's either you substitute again or you can just use the value that you got there. But very much important to know. So that means the formula for the frictional force is not the same. It depends on the situation. Can you see that part, Tetelo?
Yes, sir. I can see it.
Yes, it's not and it's never the same. It all depends on the situation, meaning is the object on a flat or is the object on a on an incline, and also the force that is being applied, that force applied, is it at an angle? Does it have the components or not? If it has the components, then it will influence the frictional force. I hope now you get it.
Yes, sir. I get it now.
Yes, okay. So now 4.5, they're asking how will the acceleration compare if the 8 kg, if the position of the 8 kg block and that are switched. So you just need to say greater than, less than, the same, and then what would be the reason? If we swap those masses, will the
It'll be
acceleration stays the same, increase or decrease?
it'll be greater
Okay, what would be the reason?
because of the greater mass going down the slope.
Yes, so normally in physical sciences, you just have to give a physical reason, and even if it's not exactly the same as what they indicated, then it should be fine. But the most important part is that the FG parallel will increase. That is why the acceleration will increase. So many reasons can be given there. Obviously, because what is it? You are adding more weight on the object which is on the incline. It will therefore have a greater weight, and that greater weight will influence the acceleration of that system. Makes sense to tell?
Yes, sir. It makes sense.
Yes, I think that's it, detail. I think that's it. Unless if you've got a question, but I'm hoping that today you were able to learn something, especially that part of the frictional force, the formula for the frictional force. So if you practice on your own and it comes, just try to find out if you would be able to understand what they've done in the memo based on that information. I think going forward, you won't struggle that much regarding interpreting the formula for the frictional force. Any questions from your side, Tetelo?
No, sir. No questions.
No questions. Okay, no, then it's fine until we meet again. Eh?
Yes, sir.
Okay, cheers, bye.